Hi everyone, today we're going to examine how we generalize the 2-key protocol to a general purpose multi-party state network solution. This is basically now on the roadmap of the 2-key labs. So all of this is a work in progress as we generalize the protocol. You can go to the 2-key labs section in our website, and also in your due diligence folders you'll be able to find the R&D roadmap. And basically what we've covered up till now is how we maintain multi-party state channels. So that's basically how we maintain a linear channel of state. Now we're going to try to understand how we can take this and generalize it when we need to sync between various chains. So in the general purpose architecture, we want to be able to play out any smart contract transaction. So let's take one of the basic examples that require cross-chain syncing, which is double spending. So, and this actually also correlates with our current architecture and how we want to generalize it. If you recall, each time we create a 2-key campaign, it comes with its own balance of arcs, which are these activation referral coins. And we want to be able to manage these balances and accounting on the layer 2 level as well. So this is just also a way for us to understand, as an example, how we avoid double spending, just as an example of this requirement to sync between parallel chains, right? Because if you're the contractor, and let's say you just have 100 arcs, so you want to be able to only spend these 100 and not more, right? So somehow if you give 60 to this guy, then you should be only able to give 40 to, I don't know, some other guy, right? And then be done with it. So first is an intuition of what we call fractal consensus, is that let's for now assume that we have a way to do that. We have a way for this player to verify that when this guy sent him just 60, he was rightfully doing so. And that's a verified transaction. From that point onwards, this player and all his subsequent graph only needs to take care about this initial state. So the idea behind fractal consensus is eventually not to require all these chains to sync all the time, but to basically recurse over the hierarchy in the spaces of time and the users, right? Because let's say we verify that this guy has 60. From that point onwards, we only need to take care of this subgraph and sync this subgraph, and then sync these subgraphs separately. So let's look at how we do this. In the first step, we're going to use, so up till now we had only participant nodes, and in the multi-party state chain solutions, we basically just self-verify. It's like a certificate chain. We self-verify the state as it's propagated. Now, when we want to start syncing with other chains, other parallel chains that are not part of my linear chain, we need to introduce minors. So up till now, we just had participants that were also self-validating themselves, if you recall from the first series. Now we basically transgress to the requirement to add a new type of player here, which are minors. In the roadmap of research and development, the first thing we're going to introduce, and this is already going to work in the CPC campaigns we're about to launch, is that we're going to use Plasma, which is a proof of authority network, which is public. Anyone can join, but it does require you to run a server. So you can't run it on a browser, but you can join if you want. And the Plasma basically will perform as a minor. In this case, as opposed to currently, when you don't need anyone to co-sign when you do any transaction or send a link, here before you send the link, it's not only that it won't only be enough to sign it yourself, you would also need to receive a signature from a miner that verifies that this transaction is rightfully generated. Now, of course, we're running the Plasma nodes. Anyone can join, but that's not the end goal, because here you need to run a server, and our intention is to enable a pure browser-to-browser network to run these multi-party state networks. But this is just an interim step, just as a proof of concept. So in this interim step, the Plasma node will act as a miner, and it will co-validate each and every transaction. So each and every player, before sending the link, will have to gain and integrate into the link a signed signature by a miner, in this case the Plasma. But we're going to have browsers as validators. So in the first step, what we're going to have is that each of these participant nodes, so all these blues are participant nodes, they're also going to interact as validators, which means they're going to listen to the Plasma. So it's going to be a two-way streak. They're going to listen in on the Plasma, and they're going to basically treasure inside their browser only the transactions that relate to them. And why? Because that will allow them, in case they do not trust all of a sudden the mining decisions of the Plasma, it will allow them to, whenever they want, send a sort of reject or dispute to layer 1. Okay, so then layer 1 basically will be able, the contracts on layer 1 will be able to receive a dispute request that contains just the transactions relevant to this browser. That's the reason it can contain it, because it's only listening into the Plasma to just transactions relating to it. So just transaction actually that came to this node or came from this node. And then it can basically then issue these transactions to layer 1 and say, look, the mining that I got, mining decisions I got from the Plasma were insufficient, please recompute them. Of course, it's much more expensive, but there's going to be an incentive model that if you can prove that what was computed by the off-chain Plasma was wrong, and you can prove it on layer 1, then you're going to get some kind of incentive for reporting this falsehood. And of course, we are going to be penalized, or the Plasma node runners are going to be penalized. This is the first stage. We call it the interim stage to the full general purpose solution. And I repeat, in this stage, basically what happens is we introduce miners. The miners are Plasma nodes. You need to run a server in order to join as a miner here. But each and every of the participants also becomes a validator node. So it is constantly listening into Plasma. It's a public network. Anyone can listen in on it. And they're just saving in their browser just the transactions that's going into them and out of them. So in any time they feel they've been cheated, for example, out of referral rewards or etc., they can basically then send all these transactions from Plasma that they've carried here to layer 1 and have the contracts on layer 1 recompute. And if there's some discrepancy, they're going to get a reward for reporting, and Plasma nodes are going to get penalized. Okay, so this is what we call step 1.